Hey, what's up, guys? It's your old pal, Mr. Cook. We're working on the Unit 6B Extra Review, and we just got through the first page. So now it's on the back page, which is just pure graphing. So it says to graph all of these out over one interval and make note of the amplitude, the period, the phase shift, where it starts and where it ends, and also the vertical shift. So you guys saw a bunch of those back when we did graphing originally with sine and cosine, secant, cosecant, tangent, cotangent. And there's a bunch of worksheets, and the worksheets have the keys on them and all that stuff, probably up on a Schoology page, somewhere. So I'm going to go through these, not super quick, but maybe for the first couple I will. It's important to note that, sine and cosecant are going to be related because they're reciprocal identities. Same thing with cosine and secant. And tangent would be, with cotangent, but we don't have cotangent up here. They all have their different properties, like, for example, sine and cosine. Originally, they're supposed to have amplitudes of 1. They're supposed to both start at 0, like that's where they're centered around 0. And then also, their periods are supposed to be 2 pi. That's the distance in the x direction of one full pattern of the sine oscillating pattern, and also the cosine oscillating pattern. And we'll see that in a second, and I'll show you how to use all this information. But just know that they have the same kind of qualities about them. They start at 0, their amplitude's 1, so it goes up and down by 1. And then their original length is 2 pi for one of their little patterns. So here's how we can go through graphing. Each and every one of these, they all should start off at 0 in the middle on your y-axis, unless they're adding or subtracting some value onto the trigonometric function. So for example, number 13, you see how you're adding a 1/3 right there, and number 14, you're adding a 6. And let's see if any other ones. Yeah, tangent, you're adding a 3 right there. Since you're adding those outside of the function, that affects it vertically. It moves the graph up or down. So if it's supposed to start at 0 in the middle for each of these, like these ones will start at 0 because they aren't adding or subtracting anything outside the functions. These ones will start at the other value. So this starts at 1/3. This one starts at +6. This one will start at 0 because it's sine. And then this one will start at 3 because we have that +3 right there. Next, I'm just going to do the amplitudes real quick. So let's take note of the amplitude. The amplitude is supposed to be 1 for sine and cosine. But if you have a number that's multiplying in front of your sine or your cosine, which I believe every one of these do. No, not this one. If you have a number multiplying out front, that's your new amplitude. And your amplitude tells you how much the y value changes. So the y value is going to change by going up and down by 2. So it goes from 0 to 2, and then up by 2 again gets you to 4. Then it's going to go down by 2, so down to -2, and then down to 2 again, so to -4. For this one, it starts at 0, goes up and down by 4, so it goes to 4 and 8, and then -4 and -8. And this one's also got an amplitude of 4, so it's going to go up and down by 4. So same y-axis is number 10. This one goes up and down by 5, so 5, and then 10, -5, -10. This one goes up and down by 2/3. 1/3 plus 2/3 is 1. And then 1 plus 2/3 is 5/3. 1/3 minus 2/3 is -1/3. And then -1/3 minus 2/3 again would be -1. So those are my y-axis for that one. This one doesn't have an amplitude up front, so remember how cosine and sine are supposed to have an amplitude of 1. That means that it just has an amplitude of 1. And that should be pretty apparent as well because, there's always secretly, because of the identity property of 1 that's multiplying out front. So this goes up and down by 1 each time. So 6, 7, 8, and then down 1, 5, and 4. This one just has an amplitude of 1, so up and down by 1, 1, and 2, and then down by 1, down by 2. There we go. And then tangent also has an amplitude of 1. We'll call it amplitude, but really, tangent doesn't necessarily have an amplitude. Same thing with cosecant and secant. You'll see that they have kind of gaps in them. They're more like vertical stretches, in a traditional transformation sense than they are amplitudes. But I digress. So that gives me the y-axes for all of these graphs. Okay. And that also tells me the amplitudes for each of these. So if I'm starting a tally of what each thing represents, the amplitude is always going to be 1 unless there's a number that's multiplying out front. And it actually doesn't even matter if you have a negative out front, because all that a negative does is that it tells you that there's going to be a reflection of the graph, you know, in a little bit. But yeah, so those are the amplitudes. You can get all those pretty easily. So remember the period. The period is like the distance in the x direction where you have one full pattern of sine or cosine or whatever you're dealing with. Now, sine and cosine have periods of 2 pi. Same thing with secant and cosecant, you know, the sister patterns that go along with the reciprocal identities. Tangent's the only one that's kind of a little bit weird. Tangent and cotangent, I almost misspelled that. There we go, cotangent. They don't really like necessarily have amplitudes, and but their starting value is like still going to be 0, like in the middle. It's like centered around 0, and their period is going to be a length of pi. So they repeat themselves over pi, and that's just simply because of the way that the unit circle plays out and the values play out and the way that they're related. If you look on the unit circle for the tangent values, you'll see that if you start at 0 and go all the way over to pi or 180 degrees, it's the exact same patterns if you were to read them off as if you were to start at 180 degrees and go to 360, or start at pi and go to 2 pi. So the pattern repeats itself every 180 degrees or pi radians. But anyway, so what that helps us to do is find all the rest of the stuff, the period, the phase shift, and then also the starting and the ending values. The vertical shift is that, you know, like the graph on the y-axis is supposed to start at 0 whenever it isn't. Like this graph got moved up 6, this one got moved up 1/3, this one didn't get moved up at all, and this one got moved up up 3. That's your vertical shift when you write it out. All right, so now for the x values. The x values can be found really easily. All you need to do, and this is the easy way to get all 4 of these values real quick, the period, the phase shift, the starting value, and the ending value. All you need to do is just take the equation that's inside the parentheses. So I'm going to underline all those because it's the same step for each one of these. Except for tangent, we'll talk about that in a second. And what you do is you set them equal to 2 values, the original starting value for sine and the original ending value for sine, which is going to be, it starts at 0, you know, just like on our unit circle, and goes all the way around for one full circle to 2 pi. So I'm setting each of these equations equal to those 2 numbers, 0 and also 2 pi. So that equation is theta plus pi over 6 is equal to 0. And theta plus pi over 6 is equal to 2 pi. This one is just going to be theta, so theta is equal to 0. Theta is equal to 2 pi. This one is 2 over 3x plus pi over 3 is equal to 0. And 2 over 3x plus pi over 3 is equal to 2 pi. And that equation is x plus pi over 6 is equal to 0. And x plus pi over 6 is equal to 2 pi. And then this one is 2x minus pi over 2 equals 0. And 2x minus pi over 2 equals 2 pi. And then this one is 1/5 x minus pi is equal to 0. 1/5 x minus pi is equal to 2 pi. Now tangent's weird because the length for tangent is, its period is pi. So it starts at 0 and goes only to pi, so x is equal to pi. So tangent's the one like weird one on this page, but all the rest of them are going to be found the same way. Sine, cosine, cosecant, secant, all that stuff. Okay, so now let's start writing out, the starting and the ending values, because that's what these find. The starting value starts here, the ending value ends here, and in between them is one full period. So I'm going to solve for x first. If I divide by 3 on both sides, I get x equals 0. That is my starting value on the x-axis. 0 is my starting x value. If I divide both sides by 3 here, I get x is equal to 2 pi thirds. And 2 pi thirds is my ending value. So that's the ending value on the x-axis. That's how I'm going to find the starting value and the ending value for the x-axis for all of these, including number 16. So just keep solving them. So theta plus pi over 6 is equal to 0. If I subtract pi over 6, I get theta is equal to negative pi over 6. So this one is going to be negative pi over 6. And then if I subtract pi over 6 on both sides, I get theta is equal to 11 pi over 6. So 11 pi over 6 for that one. Oh yeah, I better show you how I did that real quick. remember that rule that we did on the previous page where if I have radian values and I want to just use my calculator, I can just take the pi's out of the equation. So if I took 2 and subtracted away 1/6, I would get, oh shoot, well it didn't do it on this calculator. Let me do it on the graphing calculator, why not? Because I know that you guys love using your graphing calculators, right? So let's do that. So 2 minus 1/6, and then turn it to a fraction, so math frac. So you get 11/6, 11 pi over 6. That's how you can do these really easily. I'm gonna use this probably in a little bit when I have to like find the values in between and stuff. So I'm gonna use that pretty regularly. So if you didn't catch that, or if it was a little too fast for you, then we'll see a bunch of examples of it in a little bit. Anyway, so my beginning value is 0 here, 2 pi at the end. Starting value here, let's solve it. So we subtract pi thirds from both sides. We get 2/3 x is equal to pi over 3, negative pi over 3. And then multiply both sides by the reciprocal. So times 3/2, and you get, that'd be negative pi over 2. All right, so that's our starting value, negative pi over 2. And then let's get the ending value here. So let's see, subtract pi thirds. So we get 2/3x is equal to, and then that'd be 5 pi thirds? Yeah, 5 pi thirds. And then multiply both sides by the reciprocal, so times 3/2. The 3's cancel out, and I get 5 pi over 2. So there we go, 5 pi over 2. And that's our ending value. Over here, starting value, let's see, subtract pi 6, we get x is equal to negative pi over 6. There's your starting value. Ending value, let's see, x, and then subtract away pi 6, we get, what would that be? Oh yeah, we already did that one, didn't we? Minus pi 6 would be 11 pi over 6, because we did that same thing on number 10. All right, so that means that this one's going to be 11 pi over 6. And then let's solve over here. So add over pi over 2, we get 2x is equal to pi over 2. Divide both sides by 2, and you get x is equal to pi over 4. So pi fourths is our starting value. Same thing, add pi halves, so you get 2x is equal to, what would that be? So that'd be 1, 2, 3, 4, 5 pi halves. And then divide by 2, and you get x is equal to 5 pi over 4. So 5 pi over 4. Starting value, let's see here. So add over pi, we get 1/5 x is equal to pi. Multiply both sides by 5, you get x is equal to 5 pi. So that's our starting value, 5 pi. And then add pi over, so you get 1/5 x is equal to 3 pi. And then multiply by 5, and you get x is equal to 15 pi. So 15 pi. And then these ones are already set because, you know, x equals 0, you don't have to solve. It's just 0. X equals pi, that's just set at pi. So once you get your starting and your ending values, you're going to fill out the rest of your x-axes. So for this, you might need to use your calculator, or you can just kind of reason through some of these. But basically what you want to do to find the x-axes is find the average of the two end values. So find the average of these two. So like average is just adding them together and then dividing by the number of numbers. And we're going to forget about pi for this whole thing when we got our fractions, okay? So like I'm just gonna do 0 plus 2/3, okay? So that's adding them, and then I divide it by 2, and then that's just gonna be 1/3. See, look, I can just do math frac, 1/3, so pi over 3. So that gives me the middle value. To find the middle value of these two, do the average. So 0 plus 1/3 divided by 2, and then I can turn it into a fraction. So that's 1/6, so pi over 6. What's halfway between pi thirds and 2 pi thirds? You again can just use your calculator. 1/3 plus 2/3 divided by 2. So you get 0.5, 1/2. So pi over 2. That gives you your whole x-axis. And you can do the same steps for every single one of these once you have the starting and the ending value, even with negatives. So you do negative 1/6, negative 1 over 6 plus this fraction, 11 over 6, and you get that, and then you turn it to a fraction. So 5 pi over 3, so 5 pi over 3, and then do halfway between these two, so negative 1/6 plus 5/3, divide it by 2, turn it to a fraction, and you get 3/4, so 3 pi over 4, and then halfway between these two, let's see what we get. 5 over 3 plus 11 over 6. and then divide it by 2, and change it to a fraction. 7 pi fourths. So there's all of our x values for that one. Same steps over here. I guess I could do this one by hand. So 0 to 2 pi, that halfway between is just pi. Halfway between 0 and 1 pi is half of a pi. Halfway between pi and 2 pi is going to be 3 pi halves, or 1.5 pi. And then x values here, let's see here. That's a total distance of 3 pi. Oh, well, let's just use the calculator. It'll go a little faster. So I have negative a half plus 5 halves, divided by 2, and then turn it to a fraction. So it's just 1 pi. And then halfway between these two, so negative 1/2 plus 1 divided by 2, and then 0.25, that's a fourth, so pi fourths. Halfway between 1 and 5 halves, let's see, 1 plus 5 halves divided by 2, change to a fraction, 7 pi fourths. Do you see it's just the same steps over and over and over again? Because, you know, it is, you know, the same steps over and over again. Whatever. So negative 1 over 6 plus 11 over 6 divided by 2. Change it to a fraction. So we have 5 pi sixths in the middle. And then halfway between negative 1/6 and 5 pi sixths, negative 1/6 plus 5/6 divided by 2. Change to a fraction. 1/3. So pi thirds. And then halfway between 5 and 11, that's just 8. So 8 pi thirds is 4 pi thirds. So there's your answer for that one. You can use your calculator for it. It gets you the same answer. X-axis here, let's see. So 1/4 and 5/4, halfway between that would be 3 pi fourths. And then let's convert this to eighths. So 2 and 6, halfway between that would be 4. So that'd be pi on the dot, or pi halves on the dot. And then halfway between those two should be, yeah, pi. Okay, and then between 5 pi and 15 pi, that's 10 pi, halfway between. Halfway between 5 and 10 is 7.5, which would be 15 pi halves. Halfway between 10 and 15 would be 12.5, so that'd be 25 pi halves. Halfway between 0 and pi is pi halves. Halfway between 0 and pi halves is pi fourths. Halfway between pi halves and 4 pi, halfway between pi halves and pi is 3 pi fourths. I knew I was going to get that out eventually. There we go. Okay. So now I have all my x values. I have all my starting and ending values. Let's talk about what this phase shift represents. The phase shift, well, okay. Here's an easy way to answer the phase shift for every single one of these. Your first x value should be 0. If it's not 0, where has it moved? So on the x-axis, it's 0 still, so no phase shift. What about this one? It should be at 0, but it's moved over to negative pi over 6. So it should be at 0, 0. But instead it's at negative pi over 6. That's where it starts. So it's moved to the left by pi over 6. So here's an easy way to think about it. Anytime you have a negative x, it moves to the left. Anytime you have a positive x, it moves to the right. And then you just write in the answer. It's supposed to be at 0. If it's not, there's a phase shift. This one, it's negative, so it's moved to the left by pi over 2. This one's negative, so this one is also moved to the left, but by pi over 6. This one's positive, so it's moved to the right by pi over 4. This one's positive, so it's moved to the right by 5 pi. And then this one has no move whatsoever. So those are all of our little phase shifts. They should start at 0, but they aren't at 0. Period. So the period is just the difference from here to here. So you can just use your calculator for that if you want, using the same trick. Just don't divide it by 2. You're just subtracting. So 2 pi thirds minus 0 is 2 pi thirds. 11 pi over 6 minus minus a negative 1 pi 6 would be 12 pi 6, or 2 pi. So this is going to be a period of 2 pi. And another easy way to do it, if you want to memorize this formula, is to take the number that's multiplying on the x. I call it the b value in your standard transformation package for a sine function or a trigonometric function. So a times like sine of bx plus c plus d. It's that b value, whatever is multiplying on x. If you just divide that into the typical period, like 2 pi for secant, 2 pi for sine, cosecant, cosine, and secant, or just pi for tangent and cotangent, and just divide it by the b value. So watch, like it'll work. If I just take 2 pi and then divide it by the value that's multiplied on the x, 3, it's 2 pi thirds, see, same distance for the period. The period for this one, since the number that's multiplying on it is 1, it'd be 2 pi over 1, which is 2 pi over 1, which is 2 pi. The number that's multiplying on the x value, the input value is 1, so it's again going to be 2 pi, the difference for the pattern. This is 2/3, so you do 2 pi over 2/3. And then that ends up being, let's see, 3 pi? Yeah, when you divide it out. So that'd be the period for this one. You know, it's the same thing each time. I'm not going to go through it. All right, now just graph out the rest of the functions. So sine always has the same pattern to it. It starts in the middle, goes up in amplitude, goes in the middle again, goes down in amplitude, and then goes back up to the middle. And then, you know, add some curve onto it because it's not like completely linear. It does have curve onto it, so there's your sine function. And you can do that for all the sines that are on here. So like there's a sine here, so it's in the middle, goes up in amplitude, goes back to the middle, goes down in amplitude, and then back in the middle. And we get these values from the unit circle. If you need a little bit more of a tutorial on that, just don't be afraid to ask your teacher. And then since this sine is reflected, we still have the same numbers that are in the middle, but it's the amplitudes that have actually changed. So see how this one went like up and then down like that? Now this part's going to be down at the bottom, so now it's going to be down here since it's reflected because of that little negative there. And this one that was at the bottom is now going to be at the top. So here is our reflected sine curve. All right, so there we go. Those are all of our little sines. Now let's go ahead and do the cosecant, because the cosecant actually is graphed the same way as sine. You just draw those points, same points as sine. But there's something different that happens. We don't draw in the sine curve like this because it's reciprocal. Since it's a reciprocal, wherever it goes in the middle, it'd be the same as 1 over 0. So it's going to be an undefined value. So for those undefined values, we just draw a vertical asymptote. So we have a vertical asymptote through that middle line, a vertical asymptote through this middle line, and a vertical asymptote through this middle line. Then, from there, once we draw our little vertical asymptotes there, we have like these little parabolas that start to form, if you will. They basically like go up along the vertical asymptotes though, so they're never going to pass through the vertical asymptotes. So they're not like actually really parabolas, they just kind of look like them instead. And wherever you have a maximum, it's going to have like an amplitude up, it's going to have a parabola facing upwards. Whenever you have one that's an amplitude below the middle, it's going to be facing downwards like this. And again, I call them parabolas, but they're not really parabolas, okay? So there's your cosecant graph. So we have all of our sine graphs done and our cosecant graph. Now let's do cosine and secant at the same time because they're reciprocal relationships as well. Cosine starts one amplitude up because its initial ratio at 0 degrees is 1. Then it goes down to the middle and then down in amplitude, back to the middle, and up in amplitude. So then, you just put some curve onto it. There we go. And there's our cosine graph. And it's going to be the same for all the cosines. So there's one more over here. Starts the same way, one amplitude up, into the middle, down in amplitude, into the middle, and up in amplitude. See, same setting. And believe it or not, secant, since it's the reciprocal identity of cosine, is going to do the same thing. It starts up, into the middle, down in amplitude, in the middle again, and then up in amplitude. But we'll get to that one in a second. So this one, same pattern as this. Just connect the dots, add a little curvature to it, because it's curved surface, or a curved line. And there we go. There's our cosine. Oops, sorry about that. Now let's go ahead and do the secant. So secant is going to have the same kind of idea as cosecant. Wherever you see the middle values here, you're going to have these vertical asymptotes that go through them, like this. And you're going to have parabolas that are around the maximum and minimum value. So up in amplitude means it's going to be an upwards facing parabola, so to speak. It's not really a parabola though. And then the amplitude down has a downwards facing, one of those little parabola type of shapes. Just remember that they don't pass through the vertical asymptotes, they just kind of stay the same. All right, so that's secant and that's cosine. Now let's go over to tangent. Tangent's a little bit of a weird one. So tangent has, initially it starts off at the value 0, at 0 degrees, and then it goes up to 1 at the 90 degree angle, and then at 180 degrees, it's weird because it's that like I'm sorry, wait, I have this backwards. I'm moving up in 90 degree increments. Sorry about that. So at 0 degrees, it's 0. At 45 degrees, it's 1. The tangent is 1. At 90 degrees, it's going to be an undefined value. So at the halfway point, in these graphs, because remember, the graphs are always the same. You're going to have this vertical asymptote here for tangent. And then like at pi, it's also going to be at 0 degrees. So at the halfway point, it's 0, not 0 degrees, at a ratio of 0. And then in between that undefined value and then the full rotation of it, 0, is going to have a tangent of -1. So if you just like follow along the unit circle, it helps you to graph these out. And then what happens is that the graph goes from 0, it passes through that point of at 45 degrees 1, and it just goes up along the vertical asymptote. In the other direction, it passes through the point and goes down along the vertical asymptote. So this is how your tangent graph looks. All right, so that's it for sine, cosine, cosecant, secant, and then also tangent. If you need some additional help, don't be afraid to reach out to your teacher. You still have some time to practice this stuff, along with a host of other videos. Like I've gone over, probably 10 topics or something like that. Each one of these probably has a video on Khan Academy or just on YouTube. So if you're struggling with any individual one of these parts, please do not hesitate to seek outside help, okay? Either a tutor or a friend that understands this stuff or some of those videos online. Just make sure you get practice and you get some help, all right? All right, that's it for this one, and then I'm going to post a video for the group work as well.